Okay, so this video is on empirical rule and hypothesis testing. Okay, so the first thing I want to talk about is the normal distribution. And the reason we call it a normal distribution, this is when you are dealing with lots of types of data such as heights or weights or exam results, for example. And what would happen is when you plot this data in a histogram, it follows the same sort of pattern and shape. Okay, and the more data you have, the more it follows this normal curve shape. And the shape always has the majority of the data centralized around the mean. In other words, let's take adult heights, for example. The majority of people are in around an average height. And there would be fewer people who are really tall, and there'd be fewer and fewer people who would be really small. So that's why it tapers off at both ends, but the majority of the data would fall in around your average or your mean. And this is what gives this shape, this normal curve. So there is a very important relationship between the normal curve and standard deviations. Now, just a reminder as to what a standard deviation is. Standard deviation, by the way, is denoted by this sigma, okay? And X bar stands for the mean, okay? So standard deviation, as I said, remember, is basically a measurement of spread. It measures how spread out the values are in the data from the mean, okay? So it's often regarded as the average difference of the scores from the mean. In other words, how far they are away from the mean, okay? So that's standard deviation. Now, when you get your standard deviation, here's the interesting thing about the normal curve, is that we know already that it centralizes around the mean, so the mean is in the middle, but all data tends to follow the following empirical rule. In other words, approximately 68% of the data will always lie within one standard deviation of the mean. Approximately 95% will lie within two standard deviations of the mean, and 99.7%, approximately 99.7% of the data will lie within three standard deviations of the mean. Now let's explain that in an easier, more understandable way. So let's say in your maths class you have a test, okay? And your teacher calculates the mean result to be 52%, okay? So they add up all the results in the class and divide by how many there are, and they get the mean is 52%. So the class average of the maths test was 52%. They then want to analyze how spread out everybody else's result is from that mean of 52, and they work out standard deviation to be 10%, okay? Well, here's the thing about the empirical rule, okay? And the empirical rule can apply to anything that follows a normal curve. And that is that if the mean is 52, then you'll see that the data will be centralized around that 52 mark, okay? And that means that if the standard deviation is 10, then this value here is 62, this value here is 72, this value here is 82, and then here, going backwards, this would be 42, 32, and 22. So in other words, in the class, approximately 68% of the pupils will have scored within one standard deviation of that mean. In other words, 10% below and 10% above, okay? Because that's the result of the standard deviation was 10%. The result of the mean, the class average result, was 52%. So I know from the empirical rule and the fact that class tests follow a normal curve that 68% approximately of the whole group will have gotten between 42% and 62% in the class. I know also then that 95% of the group will have gotten between 32% and 72% on that test. And 99.7% of the class will have scored between 22 and 82 on the test. So the key thing with empirical rule that you must remember is that bit of information there. Those percentages, in other words, the 68%, the 95%, and the 99.7%, you need to know them off by heart. You need to be really, really, really familiar with that and know that 68% of all data that follows a normal curve will lie within one standard deviation of the mean. Okay, so the mean take away whatever you got for the standard deviation and the mean plus whatever you got for the standard deviation. And 95% is within two standard deviations of the mean. So 52 take away 20 and 52 add on 20 in this particular example. And 99.7% of the data lies within three standard deviations of the mean. So in other words, in this case, 52 take away 10 add 10 add 10. In other words, take away 30. And 52 add 10 add 10 add 10. In other words, add on 30. So know your results of the empirical rule really, really well. Okay, so here's a classic question on empirical rule. We are told that the distribution of times taken by factory workers to get to their place of work can be modelled by a normal distribution. The mean time is 35 minutes and the standard deviation is 6 minutes. So straight away what you should do is draw out the rough sketch of the normal curve. And remembering, of course, your percentages, this is going to help you out here. Since we know that the mean time is 35, that's slap bang in the middle, yeah? And then the standard deviation is 6 minutes. That means 68% is going to lie within 6 minutes of the 35. So 35 take away 6 and 35 add 6. So that works out to be 29 and 41. 95% of the data lies within two standard deviations. So 35 take away 6 again is 23. And 35 add 6 and add 6 again is, of course, 47. And 99.7% lies within three standard deviations of the mean. So 35 take away 6, which is 17. And 35 add 6, which is 53. Okay, so we've got the idea of the spread of the data here. Now we're in a good position to answer the questions. First question asks, what percentage of the workers take longer than 35 minutes? Well, 35 minutes is slap bang in the middle, which implies then that everybody that takes longer is 50% of the data. Yeah, because 35 was always going to be in the middle because that's the mean. So 50% of the workers would take longer than 35 minutes. The second question then asks, what percentage of the workers take between 29 and 41 minutes? Well, there we go. There's our 29 and 41 minutes. And we know from our empirical rule that 68% of the data lies within one standard deviation of the mean. And that's where our values 29 and 41 come from. So 68% of the data is the answer there. And part 3, what is the range of the times it takes 95% of the workers to get to their place of work? Well, here, 95% we know already lies within two standard deviations of the mean, and we've that worked out already, which means 95% of the data lies between 23 minutes and 47 minutes. And that, therefore, is the range. Okay, so now let's take a look at hypothesis testing. So with hypothesis testing, there's basically 5 key things that you need to do. Okay, so I'm breaking this down in terms of steps. Sometimes you'll be asked explicitly for each part of the step, but if you're not, just always do these 5 things with this type of a question. Okay, so let me go through the 5 things first, and then we'll jump straight into some examples, and you really see how each part of this comes together. So step 1. First thing you always do is write down the null hypothesis and the alternate hypothesis. So the null hypothesis is always the claim, and the alternate hypothesis is always like the opposite of the null hypothesis. And we'll go through that in a minute with an example. Step 2 is then to calculate the margin of error. So we basically just do 1 over square root of n, where n is the sample size, and you'll be given that information in the question. And again, we'll see that the minute we jump into an example together. Step 3, you'll work out the sample proportion. So again, this is going to be the result of your study or your survey or something, and you'll work that out. P hash, by the way, is the notation for sample proportion. So be aware of that notation and wording. Step 4, then we're going to set up the confidence interval. And the confidence interval is when we basically do the sample proportion, so what you worked out here, take away your margin of error, and then the sample proportion, add on the margin of error. And then for step 5, you will make your conclusion. Now, how you make your conclusion is, if the claim at the start is outside of your confidence interval, then you reject the claim, the null hypothesis. If, however, the claim is within the interval, then we accept the null hypothesis. And that's how you make your conclusion at the end. Okay, so let's take a look at this example here. A school principal claimed that 45% of students were in favour of a change to the school uniform. The Students' Council carried out a survey of 120 students to test the principal's claim. The results of the survey found that 42 students were in favour of a change to the school uniform. Okay, so now in this question, what they've done quite nicely is they have listed out exactly what they want you to do. So this is kind of our step-by-step process listed out piece by piece. And they'll often do that in the exam. If they don't, then you know already the 5 steps that you have to do to answer a question like this. But let's just follow what we have here. So part I is write down the null hypothesis. Now, as I explained earlier, your null hypothesis will always be the claim. So come back here. What is the claim? Well, the principal has claimed that 45% of students are in favour of a change. So that's what we'll write down here as the null hypothesis, denoted by H0, right? The percentage of students in favour of change is 45%. Write it nice, clear, in a simple sentence. And that is always the null hypothesis, the claim. Now, the alternate hypothesis, which is denoted by H1, is basically this sentence, but with the word not in it, okay? You want to keep it really, really simple and similar, but we're just going to write it as the percentage of students in favour of the change is not 45%. Okay, so that's what you'll always do for the alternate hypothesis. Basically, keep the null hypothesis and put the not in there, that word, okay? And you're going to keep it so similar and very, very simple, but it will just be what the null hypothesis is not. Okay, so now the next few steps. So we need to now calculate the margin of error. So the margin of error, if we remember, and this is what you need to remember, it's not in your log tables, 1 over the square root of n. Okay, and where n is the sample size. So what was the sample? In other words, how many students were surveyed? And so the answer is 120. So the margin of error is going to be 1 over the square root of 120, which is 0.091287. And if you look at the question, it says correct 2 decimal places. So that would be 0.09. Okay, part 4 then is asking for the sample proportion, and that would always be the next step in our hypothesis testing as well. So the sample proportion, this is to do with the results from the survey. So 42 students out of 120. So 42 out of 120. Let's calculate what that is as a decimal. It is 0.35, so there we go. That is equal to p hat, the sample proportion, the result from the sample that was surveyed. Part 5 is now asking you to calculate the confidence interval. So if you remember from our steps, the confidence interval is always going to be the sample proportion minus the margin of error and the sample proportion add on the margin of error. Okay, so this gives us the interval within which we could confidently say that the results of the sample could be generalized for the results of the whole population. So p hat, of course, is 0.35. Take away the margin of error, which is 0.09. And p hat, of course, which is the sample proportion, add on the margin of error. And so this is what we get. So what this means is we could confidently say then from the results of the sample that if 42 out of 120, which is 0.35, in other words 35%, if 35% of the sample are in favour of changing the school uniform, then within the confidence interval we could make the generalisation that we could be fairly confident that between 26% and 44% of the whole school population would also be in favour of changing the school uniform. So now, once we've got our confidence interval, then look at the last bit, which is asking at the 95% confidence level. Now, this 95% confidence level is something that they'll always talk about. This is just where your interval comes from. So don't worry about the numbers here. It's always going to talk about the 95% confidence level or the 5% level of significance. They'll always use that, okay? So that's got nothing to do with your calculation. We just want to now conclude, is the principal's claim correct? So to conclude whether the claim is correct, we need to consider the claim, which was that 45% of students were in favour of a change. Is that within our confidence interval? And our confidence interval, as I said, suggests that if the sample result is 0.35 or 35%, then we could confidently say that the whole school population result would be between 26% and 44%. So, given the claim from the school principal was 45%, that does not lie within our confidence interval. Therefore, we would have to reject the null hypothesis. Okay, so let's try another example. Press pause if you want to give this one a go. Again, they have it nicely set out in the question, each of our steps in the process, so this makes it nice and easy to follow. So off you go, press pause and see how you get on with this one. Okay, so first question asks for the null hypothesis. So what have we got here? The manufacturer of Chummy Bits claims that 80% of dog owners choose this product for their dogs. Okay, so that's your claim. So that basically is your null hypothesis, that 80% of dog owners choose Chummy Bits. The alternate hypothesis then is basically that 80% of the dog owners do not choose Chummy Bits. Okay, so then part 3 asks what is the sample size. So let's have a look. It says in a random sample of 200 dog owners, 155 chose Chummy Bits, okay, in that survey. So 200 is obviously the sample size, in other words, n. Now we need to calculate the margin of error, and we're given that in this actual question. So 1 over root n. So that's going to be 1 over the square root of 200. So that works out to be 0.0707106. We'll round that to 2 decimal places. So that's 0.07, which is the same as 7%. And now we're asked to calculate the sample proportion. So the sample proportion, if we look back to our information up here, we have that 200 dog owners in the sample and we have 155 of them chose Chummy Bits. So that means 155 out of the 200 chose Chummy Bits. So that's how we get our sample proportion. We'll get that as a decimal then. So 155 divided by 200 is 0.775. So in other words, 77.5% of the sample chose Chummy Bits. And now we have to work out the confidence interval. So remember, the confidence interval is always the sample proportion, take away the margin of error, and the sample proportion, add on the margin of error. So the sample proportion, of course, is 0.775. Take away the margin of error, which is 0.07. And then, of course, the sample proportion, add on the margin of error. So that works out to be 0.705 and 0.845, which is basically 70.5% and 84.5%. So now at the 95% confidence level, so remember that's always what they will ask, is the manufacturer's claim correct? In other words, what is our conclusion? So remember, if the claim is within the interval, we can accept the null hypothesis. If the claim is outside of the interval, we reject the null hypothesis. So the claim, if you remember, was 80%. 80% is within my interval, so therefore I can accept. So therefore we accept the null hypothesis.